If you need a little extra practice, this is the warm-up from the back of the orange packet that we normally start class with. There are 2 problems that I'm going to go through in order to help you practice setting up and using the calculator. Again, this is an optional video, only watch it if you need some more practice. So problem 1 says, in 1987, there were approximately 1.2 million cell phone subscribers. In 2000, there were approximately 110 million cell phone subscribers. Determine the value of K for this data set. Now, looking at the question, it says determine the value of K. This gives us a big hint. That tells us that this is continuous growth. So this tells us which equation to use. This tells us that we're using y equals PE to the KT. So this is continuous. So from here, we need to find K. Well, we know at our starting point in 1987, there were 1.2 million subscribers. That means our P is going to be 1.2, because we're going to count in millions. Then we have e to the k. We don't know k because that's what we're looking for. Now, we are only allowed to have one unknown if we're solving for k. So we need to somehow use the other information we were given to find y and to find t. Well, here we go. It says in 2000, there were 110 million. So 110 is going to go in for y, 110 million. Now, if I started in 1987 and then I went to 2000, 13 years have passed, so t is going to be 13. From here, I'm going to divide both sides by 1.2. So 110 divided by 1.2 is 91.6 repeating, so I'm just going to leave that as a fraction. So it's 275 over 3 is e to the power k times 13. Now, at this point, I'm in exponential form, so I'm going to switch it to log form. Because my base is e, it becomes natural log. So I get the natural log of 275 over 3 equals 13k. Now I divide by k, so I get k to be the natural log of 275 over 3 divided by 13. So if we do that in our calculator, we get k to be about 0.3475. Okay, does this make sense? Well, if k is positive, which means that this is a growth equation, which should make sense. We started out with 1.2 million and we grew all the way to 110 million. So this checks out. Now, right now, you need to make sure that you store this as x in your calculator. So you're going to hit the STO button, and then you're going to hit the X button. STO is in the bottom left of the calculator, and the X button is the upper right. The X button says X, comma, T, comma, theta, comma, N. So store this value as X so that we can use it later. Now in part B, it says, when were there 50 million cell phone subscribers? So let's write our original equation. So y equals 1.2 e. This time we have k, so 0.3475 to the t. Now it says when. This tells us that we're looking for t. So I get 1.2 e to the 0.373475 t. When were there 50 million? So 50 is going to go in for y. Again, our y is being counted in millions. Okay, at this point, I'm going to divide by that 1.2 again. So I get 41.6 repeating, so I'm just going to leave it as a fraction. So I get 50 over 1.2 equals e to the 0.3475 t. At this point, I'm in exponential form. There's nothing else that I can do, so I'm going to switch forms. Because my base is e, this becomes natural log. So I get the natural log of 50 over 1.2 equals 0.3475 t. If I divide by that 0.3475, I get the natural log of 50 divided by 1.2 over 0.3475. Now, remember, I don't actually want you to use that 0.3475. I want you to use the x that you have stored in the calculator. So you're going to do natural log of 50 divided by 1.2. Make sure you end your parentheses after that 1.2. So make sure you end these parentheses. And then you're going to divide by x, because that's the stored value that we have. You get t to be about 10.731. Now remember from our original problem that we started in 1987. So we have to add this to 1987, which tells us that we are going to hit 50 million cell phone subscribers in about 1997.